Welcome back. In this concluding video on repetition structures, I wanted to just go through a few examples with you, and I have a couple actually that I will have here, and I'll put them out in Blackboard so that you'll be able to look at them yourself, open them up, and try them out. So the first one is a program that asks the user for an age, and it validates the user's age, which we do with a simple if statement, which we actually looked at in the last chapter. But the difference is that in this example, we have a repetition structure here, so it will loop back over if the user doesn't enter the right age, if it's out of range. It'll go back and re-ask the question until they get it right. And this is done with a while loop, which, as you remember in Small Basic, the only two official loop structures are the while loop and the for loop. And so what you're looking at here is the while loop, and you can see it between lines 17 and 22. Now, if you look at the code and you get beyond the comments here, it restarts on line 14, and it asks the user for their age, and it stores the age in a variable named age on line 15. Now the line 15 here is really what we would call the priming read, because it primes the loop. It sets up the age so that we can test it, and we look at the age, and we have two conditions here: age less than 3, age greater than 130. Now the way this works is if either one of those conditions is true, it will go into the loop body, which is lines 18 to 21. And because it's an OR, logical OR here, only one of the conditions must be true for the entire condition to be true. Now in this particular case, you can't be less than 3 and greater than 130 at the same time. So we know we're never going to have both true, but we could have both false, and we could have either one or the other being true. If the condition is true, that means the user entered invalid data, in which case we go into the loop. And on line 18, we put up a message that says, sorry, you've entered an invalid age. And then we tell them what the age should be, or what is considered valid, and then we ask again, what is your age, on line 20. And then on line 21, notice it's the exact same line of code that you have on line 15. It reads again asking for the age, and then it comes down to the end while statement on line 22. That takes you back up to line 17, and it will retest the conditions. So what's happened is the user's been told that what they typed in was wrong. They're told that they have to re-enter, and they have re-entered something, and we're putting that back into age, and then we're looping back up to the beginning of the while loop and retesting. Now if they still have it wrong, it'll repeat that loop again and ask them again. But if they figured it out and put the right number in, it will test negative on line 17 and skip over all of the code until it reaches line 23, which is blank, so really effectively line 24. Now on line 24, we have a valid age at this point. In fact, you can't get to line 24 until you have a valid age. So you can safely work with age after the while loop, knowing that it has to be valid at that point. So we simply check to see if it's less than 16. Now we know it has to be greater than 0, so there's no sense testing for that. That would always be true on line 24. But we do check to see if it's less than 16. Do we need to check to see if it's greater than 130? No, that's already been taken care of. So if it's less than 16, we tell them I just noticed I have a bug in this code. This should really be if age is greater than or equal to 16, then tell them they're old enough to see the movie, else tell them they're not. So I had my logic switched around there, and of course I did that on purpose to show you guys how important it is to get your logic right. And yeah, most students never fall for that one, but it's always worth a try. So at any rate, the program does what it's supposed to do, and with your while loop there you have that validation logic. Now, I could be a purist and I could say, look, you've got this priming read on line 15, and then you've got it again on 21. And in fact, if you look at lines 14 and 15 and lines 20 and 21, you'll notice that you're duplicating code there. So if I really wanted to be a purist about that, I could make a subroutine. And I could take those two lines of code, cut them, paste them down here, put in an end sub, and then I can replace these two lines with a call to validate age. And I would also put validate age there. So, and if I run it, okay, so if I enter my age, if I do the thing right and I enter a valid age, it tells me in this case that 32 is old enough to see the movie. Now, if I run it and I put in 10, it tells me I'm not old enough. If I run it and I put in 0, it says sorry, but you entered an invalid age, and to be considered valid it must be between greater than 3 and less than 130, and it asks me to enter it again. So put 16 in there, tells me I'm old enough, and exits. So it works. So this solution here is really the best approach because it has no code duplication. Now, if you want to be technical, you could say that, well, line 14 and 19 are duplicated. Yes, that's true, but they're both just calling a subroutine on line 28. So we really don't consider that code duplication. So that is the first example I wanted to show you. Now let's take a look at another one. So in this example, we are going to take a look at a count-controlled loop, or a for loop. And what this particular program does is it asks the user for a series of test scores and calculates the average. And what's interesting about this program is that the user gets to choose how many test scores they want. And that choice is stored in a variable called number of scores. And that becomes what we call a sentinel in our for loop. Notice the for loop starts using a variable called count. That's your loop counter. It starts at 1, and it repeats the body of the loop, which starts on line 27 and goes all the way down to 42. This entire block repeats itself from 1 to whatever is inside of that variable. So if the user enters 10, it's going to run 10 times through that block of code. Now, when you're in that block of code, it's going to get the test score. Notice I put that into a subroutine, which we'll get to here in a minute, but it's going to get the test score, and it's going to check to make sure it's valid. And if it's not valid, because the score would be greater, if the score is less than 0 or greater than 100, that's considered invalid. And if that condition is true, if either one of those is true, this loop runs, and it informs the user, and then notice it calls get test score and loops back up and repeats the process. So it's our priming read and then our while loop here, taking care of making sure that the score that gets entered is valid. And so that once you reach line 40, we have a variable called sum. It's initialized to 0, and that sum will equal itself plus the score. So basically, it's going to add up all of the scores inside of this for loop. And when the for loop goes through all of the test scores, it will, what we call, fall out of the loop and take you down to line 45, where we calculate the average by taking the sum and dividing it by the number of scores. And then, of course, we just print that average test score out. Now, what does get test score look like? If I scroll down a little bit further, you can see two subroutines down here. Here is our get test score. And all it's doing is asking the user to enter the score, number, and whatever that count is equal to in our loop. It presents that. And then it accepts the number, reads it in, and stores it into score. Now the reason I put it into a subroutine is for the same reason I did this in the previous example, and that is to avoid duplicating code. So I do that in this for loop. And you'll notice also that we have a for loop, and inside of it we have a while loop. So you're nesting your loop, your while loop, inside of your for loop. So just as you can nest selection structures, you can also nest repetition structures, which is very handy to be able to do. We call the for loop the outer loop, and the while loop inside of it the inner loop. Now, all of this is great, but how do you know how many scores to loop through to collect? Well, that's back up at the top of the program. When the program starts, they're told what the program's going to do, and you'll notice here we call get number of test scores. And if you look down at the bottom, you'll notice that what that does is it writes out to the screen how many test scores do you want to enter, and it collects the response and stores it into a number of scores. Now, when it comes back, it enters into a while loop that looks at that number of scores value, and if it's less than 1, we consider that invalid. The condition will be true. It will enter into the loop. It will run lines 19 and 20. When it reaches line 20, it will go back down and call get number of test scores. So basically, if you don't get it right the first time, which is line 16, it will ask you again at line 20. And if you mess that up, it will loop back up again and continue to ask you until you get it right. So that when we reach line 24, we know that our number of scores is a valid value. We can confidently enter into our for loop below it, knowing that we're going to loop from 1 to some number 2 or higher. So when you put it all together, you have a loop here with a priming read, a while loop, and then you have a for loop, and then inside of the for loop you have another priming read with a while loop. So this structure of having a priming read followed by a while loop is really user input validation. That's simply how it's done. And then the for loop is just simply a count-controlled loop doing something a certain number of times, and if you're collecting information, you have to know how many times to ask, and that's what the for loop is doing. And then you can see here that a count controlled loop, you know how many times it's going to execute. But a condition controlled loop, you really don't know how many times it will repeat, because it's up to the user. Once the user gets it right, it'll stop repeating itself. So you can see the difference here in the loops. And what I would suggest is that you take a look at both of these programs. I'm going to put them out in Blackboard. Take a look at them and run them, try them out, and make sure that they make sense to you. So if I run this program, notice it's asking me how many scores I want. Now if I say -9, it says no, that's no good, and it asks me again. If I put a 5 there, it starts by saying enter score 1. And you'll notice it's plugging along just great. When I reach score 4, if I put in a -90, it'll tell me that that score is invalid, and it'll say try again. And it repeats, asking me for score number 4. And you can see here that, it forces you to enter good data so that the average is a valid average. What's great about a program like this is that it's bulletproof. The user can't crash it. They can't do dumb things to cause it to go down in flames. Now, granted, it's a text-based program, and a text-based program is much harder to crash because the code, there's only one path through it. The user has to follow the path that the code imposes on them. But when you're talking about a Windows-based application, a graphical interface, where you've got a whole bunch of text boxes and a bunch of buttons, you have no idea what they're going to do, what button they're going to click on, or where they're going to put text in, where they're going to forget. It's much more difficult to get a graphical application bulletproof than it is a text-based application. But the concept is the same, and these coding structures are also the same. If this were a graphical interface, you'd have a button, and you probably would have some text boxes where you'd enter the values. You'd have a button you would click, and it would look at your number in your text box, and if it didn't like it, it would pop up a message, this is entered again. But there would be a loop there that would run until you got it right, depending on how you structured your code. So the concepts do carry across into different types of programs that you'll build. So I hope you find this helpful. We could talk much more about loops, and when you take a course that commits to a specific language like an intro to Java or an intro to C#, you'll go into a little bit more detail about loops in those courses. But this course, again, our purpose is just to kind of get your feet wet, learn the fundamentals here, and that will carry you forward then into the languages that you learn in the future. So I'm going to wrap this video up here, and as always, if you have any questions at all, don't hesitate to ask. Send me an email or give me a call, and we will get in touch and get you through any hurdles that you might be having with this material. So thanks for watching, and we'll talk to you soon.